sevens, welcome to another video on the quadratic number pattern. This is video number 2, just the harder type questions that you can get where the sequence is given to you in terms of x. So there will be a missing value, and the way we're going to go about it is first we're going to find what is the missing value, what is the value of x, and after that we can find the nth term, so the general term for this quadratic number pattern. So first and foremost, they have to tell you that this is a quadratic number pattern. And what do we know about a quadratic number pattern is that it has a second constant difference. So the second difference or the second differences will be equal to each other. All right, so if we're going to go about this, we always say term 2 minus term 1 will give you the difference here, which is 6, a positive 6. Then term 3 minus term 2, which is now we've got this in terms of an x, but it's okay. We're just going to stick with it and say x minus 7. And for the next first difference, we say term 4 minus term 3, which is 31 minus x. Okay, but because it's got a second constant difference, we have to go again. And then we say x minus 7. So it's this difference minus the previous difference, minus 6. And for over here, we're going to have 31 minus x minus 7. And remember, always when we deduct two terms from a certain amount, you always have to put it in brackets so that you remember that the minus distributes or has to be applicable to both terms inside there. Okay, so then we've got x, and I'm going to simplify that, minus 13, and over here 31 minus x minus another x plus 7. So 31 plus 7 is 38 minus 2x. So now the thing that is very interesting here is that this part is equal to this part. Why? Because it's got a second constant difference. So I'm going to have to go work it out like this. And then you can find your value for x. So thus you should get x is 17. All right, now we need to go and write up our number pattern. And we had a 1, a 7, 1, 7, 17, and then 31. So we just want to quickly see, does it make sense? So we add 6. After that, we add 10. And after that, we should add 14. Okay, so it does make sense that x is 17. So now we need to find the general term for this sequence. So I'm going to quickly work it out so as not to waste your time. If you were wondering how to do that, please refer to video 1 where I explain it step by step. So I'm going to quickly do that, and then we're going to look at the answer. Okay, so just to quickly show you, I write up all my equations like this. So if I go and put a 1 in there, in the n, 1 squared times a is a, plus 1 times b is b, plus c, that will give me the first term. So there's my one equation that I'm going to use. In this second term, I put a 2. 2 squared is 4, times a is 4a, plus 2b plus c, and this will be my second equation that I'm going to use to get to this equation over here, what I'm also going to use, and the last one that's very important is over there. So sorry, I'm going quite fast, but if you want to refer back, like I said, please look at the first video where I explain it very nicely and slowly. So 2a is always equal to your second constant difference, so a is going to be 2. Then I'm going to plug it in over here, and 3 times 2 plus b is equal to 6. So 6 plus b is equal to 6. So b is equal to 0. And to get the last one, I'm going to use my last equation over here. A plus b plus c is equal to 1. A is 2, b is 0, and c is equal to 1. Then I need to work out for c. So c is equal to 1 minus 2, which is negative 1. So your general term would be Tn is equal to 2n squared plus Bn, which will make it 0 times n, which is falling away. And the last one, not a plus, but a minus 1. And I always say, please just go and test your general term. So if I replace in 1 in there, what should I get? I should get this 1. So 1 squared is 1 times 2 is 2. 2 minus 1 is 1. If I replace a 2 in there, 2 squared is 4 times 2 is 8. 8 minus 1 is 7. If I replace a 3 in the n to the power 3, 3 squared is 9 times 2 is 18 minus 1 is 17. So you know for certain that your general term is, correct. Okay, let's quickly look at one more harder one where I've given you no values and they are all in terms of x. So the way you would tackle this one is exactly the way you did the previous one. Remember, it's term 2 minus term 1, and over here term 3 minus term 2, and rather keep your brackets and go very slowly, and over here it's 10x minus 7x. Now for the second constant difference where they're going to equal each other, we're going to say, let me just simplify here, 7x minus 4x minus 2, which will give you 3x minus 2. Okay, so again, it's this one subtracted by this one, minus 4x plus 2 minus x squared, and that will give me equal to the difference here. So if I had to simplify here, that would be 3x. So it's 3x minus 3x minus 2, which will give you 3x minus 3x plus 2. Okay, that will fall away, and I'm left with a 2. So on this side, remember they are equal to each other because it's got a second constant difference, which means the same second difference. So I'm going to simplify, and then I'm going to find my value for x. Okay, I'm going to quickly pause and then work it out. Okay, and as you can see, you're going to end up with a quadratic equation. So you'll have to factorize. You're going to find two values for x. They're different. First one's minus plus, and a minus 3 times a positive 2 will give you the negative 6, and minus 3 plus 2 gives you the negative 1. So x is either 3 or x is negative 2. All right, and if we look at the beginning, sorry, I didn't state it here. I would have said over here, I would have said find the two possible values, or find the two possible values for x. That is that. We've got x is 3 or x is negative 2. And then I would have said, and calculate the two possible general quadratic formula, the quadratic pattern. So all I want you to do is to go and substitute your answers into the original and give me two possible quadratic number patterns that these two x's give me as an answer. So I'm going to quickly do that. So let's first take the x is 3. So if I replace it in here, 3 squared is 9. And then 4 times 3 is 12. 12 plus 2 is 14. 7 times 3 is 21. And 10 times 3 is 30. So what is happening? We are adding with 6. Then we are adding with 7. Then we are adding with 9. Okay, so I just want to see adding with, oh, sorry, this is not 6. It's a little bit late at night. Okay, so 14 minus 9 is 5. Okay, so every time I'm adding another 2, so it works out. You've got your quadratic number pattern. And then for the next one, if x is negative 2, negative 2 squared gives you a positive 4. 4 times negative 2 is negative 8, plus 2 is negative 6. 7 times negative 3 gives you negative 20, times negative 2 gives you, times 7 times negative 2 is negative 14. I can hear you shouting it over there. And 10 times negative 2 is negative 20. Okay, so let's quickly have a look if it works out. I say, and there you can see your pattern. Every time we are subtracting from the first to the second, we're subtracting 10, then we're subtracting 8, then we're subtracting 6. And then with the second constant difference, you can see that you're always adding 2. Negative 10 plus 2 is negative 8, plus 2 is negative 6. All right, so these are your two. I didn't ask you for the general rule as well. I just asked you to calculate the two possible quadratic number patterns that this pattern can represent, the one that's in terms of x. All right, so I hope that makes sense. Sorry if I mumbled on a bit, but I hope you understand and see that it's really, really not that hard to do, and that you can tackle these if you get them in the test. Hope you will have a wonderful day further, and thank you so much for watching. Not washing, also wash yourself, but thank you for watching. Okay, thanks. Bye.